Assalamu alaikum and very warm welcome to you and good evening, my dear students, colleagues, ladies and gentlemen. In this video, I'm going to explain homothetic functions. In the previous video, I explained homogeneous functions, and since both of these functions are related to each other, so I would like to express uh, homothetic functions in this video. First of all, I would like to define a homothetic function is the one which is formed by taking a monotonic transformation of a homogeneous function. So keep this in mind that it is a monotonic transformation of a homogeneous function. Monotonic transformations by definition preserve the order of the relationship between the arguments of a function and the value of that function. If certain sets of x's yield larger value for the function, they will also yield larger value for monotonic transformation of f. Since monotonic transformations may take many forms, however, they would not be expected to preserve an exact mathematical relationship such as that embodied in homogeneous functions. Let us suppose we have a function y which is equal to x1, x2. Clearly, this function is homogeneous of degree 2. So if you double its arguments, it will multiply the value of the function by 4. However, the monotonic transformation which simply adds 1 to a function, then f plus 1 will be equal to x1, x2 plus 1, and that is not homogeneous at all. Therefore, except in special cases, homothetic functions do not possess the homogeneity properties of their underlying functions. These functions, however, do preserve one nice feature of homogeneous functions, that the implicit trade-offs implied by the function depend only on the ratio of the two variables being traded, not on their absolute values. I'll explain that later. Now, what does it mean? Uh, Homotheticity is a generalization of homogeneity. In fact, we can show that homothetic functions are the ordinal equivalent of homogeneous functions. Homothetic function definition mathematically can be explained like as follows. Let C be a cone. A function f in the domain C is a real valued function, and it is homothetic if for every xy elements of C and t greater than 0, f of x is at least as good as f of y if and only if f of tx is greater than or equal to f of ty. One consequence of the definition of homotheticity is that Tf is equivalent to G defined by Gx, that is equal to f of t not x. By the definitions, any homogeneous function is homothetic. Here is a theorem. If a function u is homothetic and v is ordinally equivalent to u, then v is also homothetic. Excuse me. And here is the proof. Suppose v of x is at least as good as v of y, then utility of x is at least as good as utility of y by equivalence. For all t greater than 0, u of tx is greater than or equal to u of ty by homotheticity of u, and then v of tx is greater than or equal to v of ty for all t greater than 0 by equivalence. A function is called homothetic if it can be written as a monotonic transformation of a homogeneous function, as I mentioned earlier. That is, a function f of xy is homothetic if there is a monotonic function h in R, which is a real valued function R, and a homogeneous function gxy, so that f of xy is h of g of xy. The class of homothetic functions is very extensive. It obviously includes all homogeneous functions, but also many more. For example, the function f of xy is equal to a natural log of x plus beta natural log of y is homothetic but not homogeneous because f of xy is equal to alpha natural log of x plus beta natural log of y is equal to natural log of x raised to the power alpha y raised to the power beta and h of g of f of xy with the g f of xy is equal to x raised to the power alpha y raised to the power beta and h of x is equal to natural log of x. A production function that has the property that whenever we multiply inputs by factor lambda, the Malna rate of technical substitutions remain the same between all inputs. The Cobb-Douglas production function is an example of a homothetic production function. Mathematically, a production function is homothetic if whenever we multiply its input by lambda, we simply obtain the same output we started with multiplied by some function of lambda. To illustrate, let us say that we use 1 unit of labor and 9 units of capital as our inputs. The resulting output will then be y is equal to a x raised to the power alpha, x1 raised to the power alpha, x2 raised to the power beta, and that is equal to a 9 raised to the power alpha, 1 raised to the power beta. So if we now multiply all inputs by lambda, our units of output will be y is equal to lambda raised to the power alpha plus beta times a 9 raised to the power alpha 1 raised to the power beta. In short, when we multiply all our inputs by lambda, we receive as output the same initial units a times now raised to the 9 raised to the power alpha 1 raised to the power beta multiplied by alpha raised to the power alpha plus beta. When alpha plus beta is equal to 1, multiply our inputs by lambda simply multiplies our output by lambda as well. This particular type of homothetic production function is called a homogeneous production function, where the degree of homogeneity is alpha plus beta. Hence, when alpha plus beta is equal to 1, the Cobb-Douglas production function exhibits constant returns to scale. It is a production function that is homogeneous to a degree of 1 because alpha plus beta is equal to 1. Also, we may notice that since Cobb-Douglas production functions are homothetic, as we move out along a ray from the origin, such as the ray from origin 0 to point B, the Malna rate of technical substitution at any isoquant along the ray does not change. While point A, the least cost way to produce 80 units of output, uses 9 units of capital and 9 units of labor as inputs. Point B, the least cost way to produce 36 units of output, uses 18 units of capital and 18 units of labor as inputs. Thus, point B involves twice the inputs and twice the output of point A and is in fact tangent to the isocost curve. In short, the expansion path of any homothetic production function is a straight line from the origin, as we see in figure A below. So here are 3 figures, and this is figure A, and if we move from A to B, then both the inputs are doubled from 9 to 18, but the output is also doubled from 18 to 36. So here there are constant return to scale. In case we have increasing return to scale, then we have this situation, and in case we have decreasing return to scale, then we have this situation. So this is increasing return to scale and this is decreasing return to scale, and all the 3 functions are homothetic because along these rays from the origin toward B, in all these 3 along this ray, the Malna rate of technical substitution does not change. Here are some other diagrams. Diagram A shows a Cobb-Douglas production function where there are constant return to scale as I mentioned earlier, and if we move from point A to point B, then both the inputs are doubled and the output level is also doubled. In figure B, the Cobb-Douglas production function, there are increasing return to scale, and moving from point A to point B doubles both the input and the output is more than double. And here, although both the inputs are double, but output is less than double, so there are decreasing return to scale in this figure C. Figure D shows cost function associated with the Cobb-Douglas technology, where there are constant return to scale, and constant returns to scale imply a straight line cost function. In case of figure E, since there are increasing return to scale, so there are increasing return to scale imply a concave function, whereas in case of decreasing return to scale in the Cobb-Douglas technology, the decreasing return to scale imply a convex function. So this one is a convex cost function, this one is concave cost function, and this one is linear cost function. So in short, the expansion path of any homothetic function is a straight line from origin, as we can see in this figure above. Ladies and gentlemen, this was a brief review and discussion about homothetic function. Kindly like and share the video. If you haven't yet subscribed to the channel, kindly subscribe to the channel, and don't forget to click on the bell icon so that you can get timely notifications about my other videos that I'll upload for you. Kindly share various videos of this channel in various WhatsApp groups so that these could reach to the maximum possible number of people.